amazing students. This is Mrs. A, and I love math. We are here today doing lesson 16 of your Saxon Course 3 book. And let me see if I can get the glare off. We're talking about irrational numbers. And irrational numbers are numbers that are not rational. Remember, rational has the root word ratio, which means that all numbers that can be written as fractions are rational. So irrational numbers cannot be written as a ratio of two numbers or as a fraction. So let's talk about the set of irrational numbers. Okay, so here I had forgotten to write a word on my board, and the word was rational. When we're talking about being closed, we're talking about the rational numbers. Now remember, closed means that if we are to add two rational numbers together, we will stay in the rational number set. If we are to subtract two rational numbers, then we stay in the rational number set. The same with multiply and the same with divide. Okay, so rational numbers are closed under addition, subtraction, multiplication, and division. However, there is a way to get outside of the rational numbers, and that would be if we square rooted some of the rational numbers, we would end up with irrational numbers. Now, where do these irrational numbers belong on our number line? Okay, so when we're talking about square roots, we just finished talking about roots and powers, and a square root is what we would need to multiply by itself to get the number that we're talking about. So the square root of 1 is 1 because 1 squared is 1. Okay, and the square root of 4 is 2 because 2 squared is 4. But, so some square roots are rational. The square root of 1 and the square root of 4 are rational numbers because 4 can be written as a fraction, and so can 1. Okay, all integers are rational numbers. So, however, square root of 2 and square root of 3 are not rational numbers. We're going to talk about those in just a minute, what they look like when you try to do the operation on the number line. But the square root of 2 must be between the square root of 1 and the square root of 4. So the square root of 2 and the square root of 3 will be right in between here, in between 1 and 2, because that's the square root of 1 and the square root of 4, and isn't 2 and 3 in between. Okay, so we're going to get to play a little bit on the calculator. So I brought my handy dandy calculator, and I happen to have a calculator that looks like this. And you may have a much simpler calculator, which is good because you really don't have any need for this calculator at all yet. So I've got to clear my calculator, and it's not wanting to clear. There we go. All right, so now, clear calculator. So what we're going to do is we're going to put these on our calculator. Now, on my calculator, if I want to find the square root of 1, I have to enter the 1. No, I have to enter the square root first. Let me see. I got to remember how to use this. So I'm going to put in my square root symbol. And on mine, the square root symbol is right there. Now, you should have a much simpler calculator, but I'm going to put second square root and 1. Okay, so when I take the square root of 1, it looks like that when I put it in. It's got the little square root symbol, and then it puts a parenthesis underneath it. And when I hit enter, I get over here my answer, which is 1. Okay, now if I do the square root of 2, okay, so we're going to do the square root of 2. And then look at my answer. It's pretty long, isn't it? Now, that answer is long because it never really stops. Irrational numbers continue going forever, but our calculator doesn't. Okay, this calculator has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 significant digits that it is showing me, but the number itself goes on and on forever. Okay, so now remember we said square root of 3 was also irrational. So I'm going to look at square root of 3 and put it in here, and notice how long it is. Okay, it doesn't stop. But now I'm going to put square root of 4. But we already talked about square root of 4 is 2. So that is rational. And you can see how I have just a nice little 2 there. Okay, so that's my calculator screen. Your calculator may not have as many digits, or your calculator might have more digits. But the important thing to remember is that these two numbers are irrational. Square root of 2 and square root of 3 are irrational, and their division, the division or the square root never stops. It is a non-terminating, non-repeating decimal, which means it is irrational. Whereas square root of 1 and square root of 4 turn out to be rational because they wind up coming out evenly as whole numbers in this case. Okay, so top of page 104, you have a very important rule. Okay, the square root of any counting number that is not a perfect square will be irrational. And that irrational means it's going to go on and on and on forever. Okay, you're not going to see all of those digits. But if you look at these two digits here, these two irrational numbers, they keep on going. And can you see anything that repeats? Look carefully. There's no repeating pattern in irrational numbers at all. Okay? Okay, so we have example number 1, and it says, which of these numbers is irrational? Well, let's evaluate. The square root of 0 is 0, and 0 is a whole number, therefore it is rational. Okay, the square root of 4 is 2, and we know that 4 is a perfect square, so the square root is a whole number. Okay, square root of 8, we're going to have to come back to that one. Look at this one, square root of 16. 16 is a perfect square, so the square root of 16 is 4. The only one that we can't come up with is the square root of 8. Now, square root of 9 would be 3. So the square root of 8 is going to be a little bit less than 3. It's going to be 2 point something, 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 and it's going to keep on going forever. So the square root of 8 is irrational. Okay, so here is our real number system. Okay, now we usually think of the real number line. Okay, and that real number line is made up of rational numbers and irrational numbers. And guess what? If it's rational, it's not irrational. And if it's irrational, it's not rational. Okay, they never cross over. They're opposites of each other, aren't they? If it's rational, that means it can't be irrational. So, but together, they make up the whole real number line. So every number in here and every number in there will fit on the real number line. So that brings us to example 2. We have to put these numbers in order. Okay, so let's make our little number line down here. And I'm going to go ahead and put, we don't have any negative numbers. Notice we have no negatives. So I'm just going to put 0 way over here. And I'm going to, I have a 2, so I'm going to put 2. Oops, I got a 3 also. So let's just put 1, 2, 3. Okay, now let's think about these other numbers. We've got 1, 2, 0, 1, 2, 3. So 0, 1, 2, 3. We've already got everything done except for 1.2, which is about here. So we'll say 1.2. Okay, and 5/9. 5/9, the numerator is less than the denominator. So 5/9 is less than 1, isn't it? So we're going to put, and if it was 5/10, it would be a half. So 5/9 is just a little bit bigger than a half, because remember, half of 9 would be 4.5. So here's a half. So we'll just make it right here, a little bit bigger than a half, okay? So we're going to call that 5/9. And then square root of 5. Well, square root of 5 is greater than square root of 4. And square root of 4 is 2. But square root of 9 is 3. So square root of 5, I'm just going to put right about there, square root of 5. Okay, so we have 0, 1, 2, 3, 5/9, 1.2, and square root of 5. So let's put these in order. Okay, so I'm going to erase these here so I have some room to put these in order. Okay, so 0's got to go first. And then 5/9. And then 1. And then 1.2. And then 2. And then square root of 5. And then 3. See how easy it is when you put it on a number line and think about it. This is our last example. Okay, so here we're going to read it. The area of this square is 2 centimeters squared. What is the length of each side? Okay, now remember, it's a square. So isn't side times side equal to area? Okay, but the area is 2. So what squared will give us 2? And the answer is the square root of 2 squared will give us 2. Because remember, the square root symbol and the square undo each other. So the square root of 2 squared is equal to 2. Therefore, the side length is the square root of 2. So if I put square root of 2 and square root of 2, square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. There you have it. All right, so we're on our practice problem. So get your packet out and let's do your practice problems together. All right, A says if a real number is not rational, then it is what type of a number? Well, if it's not rational, it's irrational. Okay, so A is irrational. Remember that both rational numbers and irrational numbers are real. Both of them are real. Okay, letter B says which of the following numbers is irrational? So they give us -3, square root of 9, 9/2, square root of 7. Okay, so let's think about each one. -3 is an integer. All integers are rational numbers. Square root of 9 is 3. 3 is an integer. It's also a whole number, right? And that is a rational number. 9/2 is a fraction. Remember, rational means ratio. So that's a rational number. Square root of 7 is not rational. So when I click square root of 7 into my graphing calculator, which I'm going to do right now, I should get a number that just keeps on going, shouldn't I? So I'm going to do square root of 7. And look at it down there on the bottom of my screen. Let's see if I can get it just keeps on going. All right, so that is B. And C says, which of these numbers is between 2 and 3 on the number line? Okay, so we have all of these numbers here. We're looking for a number that's between 2 and 3 on the number line. Well, when we're looking at square root of 2, remember what is 2? 2 is the same as square root of 4. 3 is the same as square root of 9. Square root of 9 is 3. So wouldn't any square root in between these two be the right one? And the answer is 5. Okay, so it says which of these numbers is between 2 and 3. There's just one. This one's not between 2 and 3. It is 2. So all of these are too low. The only one that is in between square root of 4 and square root of 9 is square root of 5. All right, so here we have practice problem D. It says arrange these numbers in order from least to greatest. So here are our numbers, and least to greatest, we're going to first look and say, do I have any negative numbers? And I do. It's way down here. So I'm going to make my number line, and here's my 0, and I'm going to put my negative 0.6. Negative 0.6. It's negative, so it has to go before 0. And then here's my 0 right there. Okay, so now I have well, let me see if I copied these right. Okay, it's 1, comma, square root of 2, 3/4, 0.5. Okay, so we can do these. Now, we have some that are already in pretty easy to look at, okay? Now, let's just put a 1 right here. Okay, remember 0.5 would be right there, wouldn't it? We'll just put 0.5. And then 3/4 is 3/4. And if you were going to turn it into a fraction, it would be 0.75. But it is less than 1, isn't it? So this is going to be right here, 3/4. Square root of 2. Okay, remember square root of 1 is 1. So we're after 1, aren't we? Square root of 1 is 1. And the square root of 2, remember when we looked on my calculator, was about 1.4 something. So let's see if I can get the square root of 2 back again. I'm going to go up. There we go. That one right on the top, 1.414 is the square root of 2. So we're going to put the square root of 2 about here. Okay, did we put everything down? We have 1, we have 3/4. Okay, so now that we put them on the number line, we have to write them in order, don't we? So we have 1, 2, 3, 4, 5, 6 numbers. So here we go. We're going to write negative 0.60, 0.5, 3/4, 1, square root of 2, which is about 1.4. Pretty easy. Okay, so now we're doing E, and in E and F, we have to find the side length of these squares. So if the area is 400, remember side times side is 400. The square root of 400 is 20. So we would have 20 times 20. 20 is the side length on that square. 20 times 20 is 400. Okay, but 3, what is the square root of 3? The square root of 3 is close to 1.7. But the side length would be square root of 3, because square root of 3 times square root of 3 is square root of 9, which gives us 3. Okay, so in G, H, and I, we are to use our calculator to find the square roots of these numbers. And then we're going to round each one to the nearest hundredth. Now remember, the hundredth place is 2 decimal places. So the first thing we're going to do is we're going to write down square root of 10. Oops. Let me get this thing to where it's not showing me an error. There we go. So the square root of 10. Okay, so you can see the square root of 10 is 3 point something, which makes sense. Remember, the 9 is 3 squared. So the square root of 9 is 3 exactly. So the square root of 10 is going to be 3 and a little bit. And it says 3.162277766. But since we are writing to the nearest hundredth, and you see how the second place is a 6 and the one after it is a 2, so we will round down. We will not, we'll just clip it off there. So we'll have 3.16. And then the square root of 20 . Okay, the square root of 20. Now let's think about the square root of 20. 20 is greater than 16. The square root of 16 is 4 exactly. The square root of 25 is 5 exactly. So doesn't it make sense that the square root of 20 is right in between those two numbers? Okay, so since 25 is 5 squared and 16 is 4 squared, the square root of 20 is right in between 4 and 5. And it looks like it's 4.472. Since it's a 2 after the 7, it's going to be 4.47. Okay, now remember, when we write these, we are rounding. These are not exact answers. Okay, so let's even these right here. If I were to carry it out that far, that's still an approximation, because what does that number do out here in my calculator? It goes on forever. Okay, so square root of 40 is going to be square root, clear, square root of 40. And look at that, square root of 40. Now let's think about square root of 40. Remember, square root of 36 is 6. So square root of 40 should be a little bit bigger than 6, shouldn't it? And it is. Okay, the square root of 49 is 7. All right, so 6.324. Since 4 is less than 5, we're going to round down. We're going to have 6.32. Okay, so let's look at our question here. There are our answers. Let's look at J. It says refer to your answers in problem G, H, and I to answer this question. Which number is twice as much as the square root of 10? Okay, well, the square root of 10 is 3.16, and the square root of 20 is 4.47, but that's not twice as much as 3.16. But if I multiply 16 by 2, I get 32, and 3 by 2, I get 6. How does that happen? Why is square root of 40 twice the square root of 10? Okay, so that's what we just discovered. The square root of 40 is twice the square root of 10, or 2 times the square root of 10. All right, so let's do a little bit of stuff that we'll go into next time. The square root of 40 can be split up into pieces. We can say that's the square root of 4 times the square root of 10, and the square root of 4 is 2. 2 square root of 10 is the same thing as square root of 40. Isn't that cool? Now we're going to come back and do a few more problems, and we're going to be done with this lesson. Okay, so here we're looking at 108 miles. So Bonnie drove 108 miles in 2 hours. What was her average speed? Okay, speed is usually in miles per hour here, since we're talking about miles and hours. So we're looking for miles per hour. So now when we're doing miles per hour, don't we assume that's 1 hour down there? So our ratio right now is 108 in 2 hours. Don't we simply need to simplify this by dividing by 2 and dividing by 2 on the bottom? So we're going to get 54, which is half of 108 in 1 hour. So 54 miles per hour is the average speed. Okay, so number 2 in your written practice says, before the gift was revealed, only 2/7 of the crowd guessed correctly. If there were 294 people in the crowd, how many guessed correctly before it was revealed? Okay, so we have 2/7 of 294 people. So 2/7 times 294 people. Okay, now we have a pretty easy problem because 294 is completely divisible by 7. Okay, so 7 goes into 29 4 times with 1 left over. Okay, so we're going to cancel this and this, and we're going to get 4 with 1 left over, which leaves that 14. 2 into 14 is 7. Okay, so you need to practice that mental math. You see what I did? I said 29 divided by 7. It was 4 times. I put down the 4. But then when I did all that subtraction, I had 1 left right here. 29 minus 28 is 1. Then I bring down the 4. That makes it 14. 14 divided by 7. Oops. 14 divided by 7 is not 7. It's 2. I'm glad I checked that. It was 42, not 47. Okay. So, because that was 14 divided by 7 is 2. I'm glad I fixed it. So we got 42 times 2 is 84. So 84 people in the crowd guessed what the present was before they did it. Okay, let's look at number 3. It says, Roger completed 28 of 41 math exercises during school. How many exercises are left for him to complete after school? So he did 28 out of 41 that he has to do for homework. So how many are left? This is a subtraction problem. Okay, and when they're doing your subtraction, sometimes they'll say separate, how many more? I don't really worry about the plot a whole bunch, okay, but you should say at least subtraction, okay? So we're going to say 41, take away 28, gives you how many he has left. Remember, we have to provide an equation, and since we're subtracting 8 from 1, that doesn't work, so we're going to make this 3 and make this 11. 11 take away 8 is 3. 3 take away 2 is 1. So he only has 13 problems left to do when he gets home. All right, we have a few more problems. And this is number 4, Major League Baseball. In 1960, there were 2 leagues of 8 teams each. Okay, by 1998, the total number of teams had expanded to 30. How many teams were added from 1960 to 1998? Okay, so now there were 2 leagues of 8 teams each. So if there are 2 leagues of 8 teams each, then I'm thinking that there were 16 teams. Okay, 2 leagues of 8 teams each. By 1998, the total number of teams had expanded to 30. How many teams were added? Okay, so we had 30 in 1998, and we had 16 because we had 2 leagues of 8 teams each. So aren't we going to do 30, take away 16, and that's going to be what? Since I can't 0 minus 6, I'm going to have to do this. And 10 take away 6 is 4, and 2 take away 1. So there are 14 more teams added between the 2 dates. And The last little bit says simplify. We have the cubic root of 64. So we have to think, okay, what multiplied by itself 3 times is going to give us 64? And the answer is 4, because 4 times 4 times 4 gives us 64. And 10 cubed means 10 times 10 times 10. And that's going to be, remember, you put down the 1 and then you count how many zeros. That's going to be 1,000. We are through with lesson 16. And this is Mrs. A. And may God bless your day.